Yes. Hello everyone. Welcome back to PiSquare Academy. I think somebody is trying to mock me, Praveen, in the comment. Nice to see that. Good one. Yes. Welcome back to the session once again. Wednesday session. We're at power electronics. Right? Power electronics 1. So, yes. Welcome back. Have a great day to everyone. Hi Encyclopedia of Triple E. Hi Anisha. Hi Dhanvat. Hi Sham. Who else is there right now? Everybody say hi so that I'll get to know who are there live now. Hi. Sambodhi. Very good evening. I'm good. Yes, Naresh, Vishnu, Aisha, Chandra Prakash. That's it. Hello Arjun. Okay, you're back. Nice. We're ready. Okay. Let's begin the show then. This is my second class. Okay, great. Let's begin the show. Today's show is all about, it's not a show, it's a lecture. It's a practice session rather. I'm here with today some SPDCL and GENCO questions, like a distribution company and a GENCO questions. So, of power electronics, this time I think session will be interesting because something really interesting questions we have today. It seems like you must be, things must be clear, but you'll be trapped. There is a trap almost in every question. Okay, get ready for the session. Now, thumbs up, give it a like, and share it. I'll wait for your share. I'll also share meanwhile if I can. You also share quickly. Share it with your friends in your groups. Now, meanwhile, if you have any questions from any one of our previous videos, maybe our Y series question, we have really special Y series question, and in which we're discussing a lot of Y series like Y 50 Hz, Y 11 kV, Y 3 phase. There are many Y kVA, Y AC in turn. Okay. So tell me in the comment which Y video you liked it. Give it in the comment. And if you have any question or any clarification regarding any one of our published video on YouTube, you can give it in the chat box so that I'll try to clarify that. Okay, Madhur has liked Y3 phase. Okay. In the Y 50 Hz video, I have given very good historical analysis. Okay, very good historical analysis I have given. There, if you watch that historical analysis video in the Y series, then you will be knowing a lot of other things. Like you will get to know why we are going for a Scott connection. What is Tesla, what he has done, what's the great contribution he has made. Everything you'll get it if you go to Y series. Yes, Y transformer and kVA. Yes, okay. So, no questions then? Yeah, I think I heard this armature reaction video from many people, almost everyone. Everyone says armature reaction is fantastic. What is secondary breakdown? Again, I'm saying you have to ask question, not any question. You have to ask a question, clarification, not a question rather, clarification regarding any one of our published video. Okay. If you're having any question on published video, whatever the videos we published, then I'll try to clarify that. If I take up a new question, it will be all new discussion once again. So, yeah, animations, good. No particular videos, sir. Everything what you have done, hats off, and great fan of you, sir. Thank you, Anusha. Thank you. Thanks to my PiSquare team also. I'm really grateful to my team. It's not one person effort, you know. My team is doing a lot of work to bring those lectures to you. Okay. We'll be giving some content and we'll be sitting along with them. There will be a lot of sittings and they will be animating the things the way we want, and I'm a tough guy. Okay, I'll be asking for many changes. I'll give an idea. Once I give the idea, while developing the idea, while designing the idea, I had to do a lot of changes. I'll get a new idea, I'll ask them to change that way, I'll ask them to change this way. Okay. Dangerous song. Yeah, there is a lot of songs in the, lot of entertaining elements which relates to your content also. Okay. Anyways, let's get into the show. The first one, the first question. Are you all ready? Give it a thumbs up. Have you shared the video? Have you shared the video? I think I have not shared the video. Share the video. Give it a thumbs up. I'll move to the first question. Yeah, we got 20 likes. Okay, let's move to the first question with these 20 likes. Okay, I got some energy with the 20 likes. Yep. First question, timer is running on screen now. Let's go. Yeah. Oh, Shanmukh was asking a question regarding 11 kV. Okay, I'll give you Shanmukh after this question. Yeah, tell me what is your query on that. I think maybe next time I'll make a phone call session also during the live. I'll make a phone call. I'll ask for a phone call. You can call and ask such kind of questions. Then with the two-way communication, things will be much better. Okay, let's plan in the next session for the previous questions. Okay. Thank you, Arjun. Yeah, time's up. Any answer? Wow. Encyclopedia has answered. Of course, he's after all encyclopedia. He must be knowing the answer. Adarsh Dhanvat. Dhanavat, sorry, not Dhanvat. Anal Chandraprakash Shanmukh has responded. So why others are not responding? Is it because you're not knowing, or what's the reason? You're not trying, just watching. You need to give it a try. Whether it is right or wrong, that's a different thing. First you need to think, right? First hit the like button, then think. Hit the like button and think. You're hesitant to hit the like also. And those who are watching, ring the bell, subscribe and ring the bell so that whenever I come live, you will automatically get notification. Okay, otherwise you might miss because of your busy schedule with your boyfriend or girlfriend. Okay, so you might miss the session. So ring the bell so that you are not going to miss. Yeah, coming to the answer. Understand the question properly? Yes. Yes. This is the answer. A separately excited DC motor operating in first quadrant fired from three-phase semi-converter. Okay, and if freewheeling diode is open circuited. So here, three-phase semi-converter is having a freewheeling diode. Means what? It's actually, you have to interpret the question. First of all, interpreting the question is a key aspect. Okay, you need to interpret the question properly. So this is a full converter. This is a diagram which I have given for three-phase full converter, simple diagram. Okay, then it is having a freewheeling diode. It is having a freewheeling diode. If it is having a freewheeling diode, then this becomes a semi-converter because it operates only in one quadrant. It's not going to give negative average value. Okay, so it only gives positive average value. That makes it, see here, this is I, this is V. Okay, that makes it to operate in the first quadrant. Now the moment this freewheeling diode is got damaged, it's open circuited, then the voltage could become positive or negative. That depends on the alpha value. If alpha ranging from 0 to 90, then it is positive. V naught average is positive. If alpha greater than 90 degrees, V naught is negative. Okay, so but current is always positive. This is a converter. See, converter current always goes in this direction. Always goes in this direction. So current is always positive. Okay, current is always positive. So current never go in this operation for this converter operation. So voltage can be either positive or negative. This is alpha less than 90 degrees. It is alpha greater than 90 degrees. Tell me what will happen if alpha bloody equal to 90 degrees. Alpha is equal to 90 degrees. I think I'm using this bloody word recent times a lot. I should reduce. I'll reduce. Alpha is equal to 90 degrees. So what's gonna be the V naught value? V naught average value. Tell me. V naught average value on alpha is equal to 90 degrees. Yes, I want you to respond. I want you to respond. Respond. Give it a thumbs up. Yes, Ananda responded correctly. Ananda responded correctly. Alpha is equal to 90 degrees means 0. Yes. So now, anyways, for this question, this is answer. Are we good to go? Are we good to go? Now, somebody has asked a question. Let me just take up that question. The question is, what happens? What about 11 kV? Why 11 kV? Somebody is having a question. Who is that? Shanmukh. Shanmukh. What is the question? Can you say the question now, or we'll talk to maybe in the next session over phone? We'll arrange a phone call sessions next time. That make more sense. Okay, I'm moving to the next question, by the way. Yeah. Move. Simple one. Not a tricky one also, a simple one. Okay, Shanmukh, good to go. Try with this. Today's questions are really interesting questions. Seems to be level 1 question, but yeah, tricky ones. Really tricky ones. Wow. Good, Dinesh. Good response. Eight seconds more. 4, 3, 2, 1. Bam. Yes, most of you guys answer correct. The answer is this. Careful. The output voltage of single phase bridge rectifier. Now, whenever this question is given something like this, bridge rectifier, it is a full bridge. Full bridge. Okay, there is no half bridge. Okay, you can call it as a half wave, but there is no half bridge. It's a full bridge. When there is a given bridge, take it as a full bridge. In case of a full bridge, the output is, this is the input. The output will be, where will the output? This is going to be the output. Okay. So the relation between output time period and input time period is this. This is the output time period. This is the output time period. This is the input time period. This is the output time period. What is the definition of time period? I think you must be aware of definition of time period. Don't say inverse of frequency. Okay. Anyways, it is said output voltage is the time period is, this time period is having how much? This time period is having 25/3 milliseconds. Okay. So tell me what will be the input time period? If output time period is this, input time period is twice, right? So input time period is 50/3 milliseconds. 50/3 milliseconds. Am I right? 25 into 2, 50/3 milliseconds. Now what we want? We want the frequency. So take a reciprocal of this. That is 3/50 milli also. You need to take care of milli also. Milli, once you flip that, it's going to be kilo. Okay. So if you solve it, you're going to get this answer. Okay. You will be getting this answer. Good one. Very good. Very good. Good response. Let's move to the Next question. Give it a thumbs up. Give it a thumbs up. Give it a thumbs up. Taste the thunder. Give it a thumbs up. Give the like. Give it a thumbs up. No likes. No thumbs up. What's this? This is crazy. Yeah. Okay. I'm moving now. Yes. This is a fun question. Just think about it. I'm giving 30 seconds time to this. I'm just giving 30 seconds for this. Try. This is a good piece. This is a good piece of question. Yeah, when you're giving thumbs up, I'll get to know who is there live, who is active, so that you can get some interesting coupons, free test series you can get. I'll be announcing a free winner today also. I'm giving every day, I'm giving for one person, I'm giving a free test series from exam.pit.in online test series. You can also just buy the test series, it's just ₹99. Okay, you can get the test series for just 99. Wow, smart. Good answers, good response. Good response. Anyways, time's up. Let me answer this. The input current of three-phase AC voltage regulator is found to be sinusoidal. Then the type of load is. Input current is sinusoidal. Input current is sinusoidal. That is possible only if you have resistive load at 0 degrees, no firing, just like a diode case, no firing, okay, just like a diode case, alpha is 0 degrees, resistive load, then input will be sinusoidal, output also will be sinusoidal current. But when alpha increases, some portion of input voltage will be clipped, isn't it? Some portion of input voltage is input voltage is clipped at the output. So as it is a resistive load, current will also be clipped. Output current is clipped, input current also got clipped. So except from alpha is equal to 0 degrees, nowhere with a resistive load you are going to get sinusoidal input current. So this can never be the answer. Okay. And this is a popular thing, not for capacitors. Capacitors, you try drawing AC voltage regulator, you're not going to get sinusoidal. And for inductive, if you see, inductive, just consider a single phase supply. Consider a single phase case. This is a single phase case. In case of RL load, what you'll be getting is, suppose current might change from here, something like this, RL load we're talking about. There will be some portion might clip over here and it may go like this. It depends on the firing angle, what kind of firing angle you're using. But if firing angle you're using only L load, purely inductive load, then you will exactly get current like this, output current, even in case of single phase. I'm talking about single phase, so you can extend the same concept to three phase also. Okay, so if it fires here, if it fires at 90 degrees, then you will get this, because current and voltage in case of RL circuit, L circuit, inductive circuit, pure inductor, it is 90 degrees. So you just fire at this instant, okay, at 90 degrees, then it will go like this. Again at 90 degrees, it will go like this. If this would have been a RL circuit, okay, you need to give the firing signal, when phi is equal to alpha is equal to phi. At this instant, you should be giving firing signal, then you will get a pure sinusoidal once again. Okay, as in this case, R is 0, only L is present, means phi value is 90 degrees, so alpha is equal to 90 degrees. Okay, yeah, let me take your questions now. Take 90 degrees firing angle, good. Not that the current amplitude is less than the voltage. Sorry dear, I didn't get what you're trying to say. Anyways, let me just move on to the next question. Okay, careful, this analysis is important. Okay, I'm moving to the next question. Okay, note that the current amplitude is less than the voltage. Yeah, of course, yes dear. It's not necessarily less. Okay, if I take that seriously, of course you're right, but if I take your statement seriously, it's not necessarily less. It depends on the value of L and the value of frequency, right? Just for the sake of clarity, we exaggerated a bit. Okay. Okay, moving to the next question. Interesting, the one who answers this question, the one who answers first correctly to this question, I will give you a test series for free. Okay, next question. Are you all ready? Are you all ready? Give it a thumbs up. Those who like the video, give it a thumbs up in this chat box so that let's move to the offer. Yeah, free test series for free for one person who responds correctly first. Okay, that's a deal. Are we good to go with the deal? Yep. Your timer has begun. Within this timer, you need to respond, of course. Yeah, 30 seconds is good enough for this. I'm giving 30 seconds. I'm giving 30 seconds. Wow. Oh, Rahul is back. Where are you, Rahul? I didn't see you so far. Govind. See, though people have answered, you could be the one who is answering correctly. So give it a try. Yes, time's up. Time's up. So, yeah, interestingly, out of all these answers, Mr. Rahul is the only one who has answered distinctly from others. Everybody has said C, 2 and 1, but Rahul is the only one who said the distinct answer, that is 72. Now Dhanavati is also saying same, Ramesh is also saying same. Yes, this is the right answer. Again, today's winner, you dear Rahul. Give your email ID right now. Give your email ID. Oh, pada hai, acha. Give your email ID. You are the winner now. Test series. Give your email ID. I'm waiting for your email ID. Give it. Give your email ID. Yes, I got it. Okay, now careful here. Careful here. We use, in case of a 3-phase to 3-phase cycloconverter, okay, normally 18 SCRs are used, if it is 3-pulse cycloconverter, okay, and when you are increasing more and more pulses, then the harmonic content will be less. Okay. Next, 36 SCRs, that's be 6-pulse cycloconverter you can call. This is also used for cycloconverters. This is rather most popularly used in industries for their drives applications. Okay, VBF control applications. These are most popularly used. Okay, and if you want even better output, I mean, with less harmonics, you go for double to this, that is 72 SCRs. Of course, as you're increasing more number of SCRs, complexity is gonna increase a lot. But you want an effective harmonic free, distortion free output, so you will get with this. Okay, but generally this is the most preferred, and this is what you might have studied. Most of you might have studied about this only, but these are the cases. Yeah, these answer right now. Give another chance. Yeah, let's see dear. Let's see with the next questions. You'll keep getting the chances. Every time you'll be getting chances. Every session you'll be getting chances. Let's see. Okay. Yeah, I'm moving to the next question. Answer this. I'm giving 60 seconds to this. 60 seconds running now. Give it a thumbs up. Give it a thumbs up. It's not about a question and answer. Analysis is also important. Analysis. You need to analyze the things properly. Okay, you need to learn the analysis. You need to understand the analysis. Don't be in a hurry to give quick answer. don't be in a hurry to give quick answers. I'm saying again, don't be in a hurry to give quick answer. You need to be correct, try to be accurate first. Then, yeah, once you got your accuracy, then you can focus on obviously the speed. First of all, accuracy matters. No dear, matrix converter is something different. Matrix converter is something different. This is something different. Yeah. Yes, Rahul, I got him mail ID. I got him mail ID. Yes, I got it. I got it. Others can't see it, but I can see it. Okay. Million. Okay, time's up anyways. See, I don't know why most of you guys have answered wrongly. Most of you are answered wrongly. Let's see the correct one. If the active input power of a single phase semi-converter with RL load is 200 watt, okay, at a firing angle of pi by 3. Clear? Active input power single phase semi-converter is this. Then, neglecting the harmonic component of the output current, calculate the reactive power input. What is input power formula? P is equal to V I cos phi. P is equal to V I cos phi. Okay. Now, I'm taking here, this is continuous conduction mode. I'm considering continuous conduction mode. RL load is given. So I'm considering continuous conduction mode. Okay. So I can consider this phi for power. I can consider alpha as a phi. I can consider, because continuous conduction mode, alpha and phi both are same. Okay. So phi is not 90 degrees. It is pi by 3. Alpha and pi both are same. RL load, not L load. So this is how much? That is equal to, P is equal to how much now? 200. Okay. Now, it is asked for the value of Q. Q is equal to how much? What is the formula for Q? Q is equal to Vi sin phi. Q is equal to Vi sin phi. So now, from this, phi value is known to you, that is pi by 3. Phi value is pi by 3, which is known to you. Now, once you know Vi value, you can get the value of Q. Right? So, what is the value of Vi? That you can find it from here. From here, you can get the value of Vi. What is Vi? 200 by cos pi by 3. Okay. Cos pi by 3 is how much? How much is the cos pi by 3? Cos pi by 3 means 60. Cos 60 is, I think, 1 by 2. Yes. So, you will get 400. Vi is 400. So, this is 400. Right. So this is sin 60 is root 3 by 2, right? So you will get this is answer. Okay. 2 is answer. Who answered 2? Govind Reddy has responded first to this question. Yes, you're right. Let's move to the next question quickly. We have a few more interesting questions. Next question is easy, but you analyze a few more things along with the next question. Okay, not just answering the next question. You can easily answer it, but analyze surrounding things also. Think about the other things as well. Yeah, move to the next one. I'm just giving 40 seconds to answer this. Maybe you can analyze after you give your answer to the question. The timer is running here. You can see the timer running, ticking. What happened to you guys? This is a simple question. Subhashish Skar, it's good to see you. What the heck? What happened to you all? Most of you are giving wrong answers for this simple question. This is not expected. This is a fundamental question. With this itself, it's very clear how nice is your preparation. It's not happening smooth. You need to gear up your preparation. At least these simple aspects, that 180 degrees and 3-phase converter, you have bloody two things, that is 180 degrees and 120 degrees mode. It is asked for what? Peak to peak output of line voltage here, line voltage here. In both the cases, be it 180 degrees, be it 120 degrees, in both the cases, you will get peak to peak voltage is 2 times of VDC. 2 times of VDC, not no Shanmukh. 2 times of VDC, peak to peak. Peak to peak means not just peak. Not just a peak, it is a peak to peak. This to here, total. Okay, total, that is for line voltage. You should focus on line voltage, not the phase voltage. It is line voltage. So, both configurations, 180 as well as 120, it is 2 VDC. So, answer is this, 2 times of 100, that is 200. Now, if this would have been asked for a phase voltage, then yes, you need to apply. If it is a 180 degrees conduction mode, then you'll get stepped waveform for phase voltages. Okay, tell me what will be the answer for this 180 degrees conduction mode. The question is 180 degrees conduction mode, it is asked for phase. Suppose if this would have been the question, then what is your answer? Tell me. What is your answer? Tell me. Yes, yes, this would have been the answer. Okay, clear? What if this would have been 120 degrees conduction mode? 120 degrees conduction mode? Yeah. Just that's how you need to analyze one question during your practice session. If one question comes, you need to create a next question and think about it. Okay. Anyways, I'm moving on. Dear Syed, I understand your concern, but that's not possible, dear. Reading the question is not possible right now. You can watch the rebroadcast. Okay, you can watch the rebroadcast once the live session is over. You can watch the rebroadcast. That makes more sense, I think. Okay. Yeah. Moving to the next question. I think let me zoom a bit. Zoom in. Should I do that? I think it's not possible, maybe. Yeah. Move to the next one. Get your calculators ready. 60 seconds is more for this, but yeah, I'm giving just for the sake of getting your calculators quasi-square. Yeah, right. What is seconds left? Do you have calculators handy with you? No, I think, right? Thank you, dear. Thank you, Anand. What the heck? No correct answer so far. 3 seconds, 2 seconds, bam, time's up. This is a simple question. Yes, dear Karthikeyan. Yes, I think you're right. It's supposed to be the answer. If you have a calculator, then things will be much better. Anyways, the input voltage of single phase full wave AC voltage controller is AC voltage controller or AC voltage regulator. This input voltage, if the load is resistive load and output voltage is 162, then the input power factor, we know input power is equal to output power. Input power is equal to output power. V input I input into cos phi input is equal to V output into I output into cos phi output. What is the output power factor? That is 1 because of the resistive load. This is 1. Okay, and as it is AC voltage regulator, this current is cancelled. Okay, both are same. So now this is 1, both are cancelled. So input power factor is equal to simply V naught, of course RMS value, by V input RMS value. So V naught RMS is given as 160. Careful here. Should I take V input RMS as this as V input RMS, 282.8 as RMS? Should I take that? Okay, let me just check it. If I take that, how much you're gonna get? If you take that, you are getting 0.573 as answer, but that is the wrong one because this is not a RMS value, this is a maximum value. Yes, you're right, Nikhil, you're right. I should take by root 3. Why I'm doing root 3? It's root 2. Okay, so if you do that, then you will get this as answer. Okay, you should be careful with such simple things. Okay, that's what I've been saying always. Fundamentally, if you're good enough, if your fundamentals are good, then things will be much better. Even though if you miss the formula, you can quickly derive if you know the fundamental concepts. Okay, and of course I must say you're knowing the concepts, but when time comes you're unable to apply those concepts. That's the biggest concern for most of the students. That's what I'm saying always. Even in my course, I given by keeping that point in my mind, I designed the course. In case of power electronics, most of the people think there are a lot of formula in the power electronics, there are a lot of waveforms in the power electronics, but if you see our courses, there I think just based on one formula, just bloody one formula, we could make 40 formulas almost just for one formula. You don't have to mug up or you don't have to remember the formula. You have to just take that one formula and you can apply and you can get very quickly, maybe in just 5 seconds you can get the actual formula, just one formula. Okay. Anyways, let's move to the next question. Yeah, this is theoretical question, so I'm giving just 40 seconds. I think most of you will give fluke for this. Don't just give a fluke. Just guess. Try to give the right one first. Think first. You have 40 seconds time. Think about it and just check what could be the possible nearest one. What do you think the reason is? Good. Yes. Good. Time's up, by the way. SCR is the only device we are sticking with, though it is a semi-control. Of course, track is also semi-controlled. I'm not saying track is fully controlled. SCR both are semi-controlled. But SCR is the only device still we are sticking with SCR, though it is a semi-controlled, just because of their availability of higher rating. This is the highest power rating available device. That's why, it's utilized. If you have to use SCR in case of track, means there is the only reason, one of the best reason rather, which takes us to this is availability of high ratings. Okay, good. Next question. Wow, try this. This is a good one. I mean, most of the times this is asked. So please take analog class once. Sorry dear, I'm not the right person to take analog, I think. See, if somebody is taking subject, means one has to be pro in that. It's not just knowing the subject, right? Everyone knows the subject. You know the subject. I think you know better than me. One has to be pro, so I can't. So, yeah. Time's up. Okay. Those who are saying answers, can you just brief it? If you can give it a brief, can you just briefly give a comment why you are choosing that option? Those who are choosing the option, just give it a brief. And give it a thumbs up. Those who are live, give it a thumbs up. Give it a thumbs up. Yeah, I think you might be writing. Let me just move to my explanation. Which type of commutation results the best performance? Load commutation, supply commutation, or natural commutation, they are just commutating. They are not going to give you best results. These forced commutation techniques are going to give you the best results because you are forcing the commutation to happen. Obviously, when you are forcing something, the performance will definitely be better. Okay, it's not just using the parameters, whatever is there inside. You are forcing something to happen, such a thing. So obviously, forced commutation works better than any other commutation techniques. Okay. So these two are not forced commutation technique. These two are the forced commutation techniques. So you should not choose any one of these, even with an accidental case also. Now people should get confused. Okay, that could be a valid reason even if you say any one of these. But now this is the right answer. The reason why this is the right answer is if you see current commutation technique, their first point, you don't have to have initially charging capacitor. Okay, I should not say it as a first point, but this is one of the point. You don't have to have initially charged capacitor, but in case of a voltage commutation, you have to have initially charged capacitor. And the main reason quite naturally is here in case of voltage commutation, the rating of the SCR is much more than the load capacity, load rating. If load rating is 100 amperes, you should buy an SCR which is definitely higher than some current, that is current flowing through SCR is capacitor current plus load current. Okay, what is capacitor current value? √3 times of C by L. Yeah, this is the one. Okay, so this much current is extra going through this. Okay, peak current I mean to say. So you need to buy a little higher rating of capacitor. So these are the reasons why normally we prefer current commutation. That's what my analysis. So I prefer answering this. Okay, let's move to the next question then. Give it a thumbs up. Thumbs up. Give it a thumbs up. Then I'll move to the next. Otherwise I'll not move. I'm not moving. I'm not moving. I'm waiting. I'm waiting. Yes. Moved. A simple piece. This is a simple piece. Good. Aman. What other guys are doing? They're not participating. I'm not asking you to answer also. I'm asking you to give it a thumbs up. For giving thumbs up, not a thumbs up what is available, the Coke, the soft drink. Yeah, that's what I want. If you are hesitant and lazy to bloody hit that, how crazy guys and girls. Wow. Anusha, smart. Yeah, anyways, time's up. Answer is √3 by 2. For a single phase fully controlled rectifier feeding a constant direct current into a load is 30 degrees. The firing angle is given as 30 degrees. It is constant direct current means continuous conduction mode. Okay, with of course constant current. Then the displacement power factor is simply cosine of this, cosine of alpha. Okay, cosine of alpha cos 30 is this. Straight answer. And guys, careful with these performance parameters. Most of the times if you are attempting any state government exam, there are high chances that there will be a question based on these performance parameters. Okay, maybe THD or harmonic factors. These are the simple zones. In that simple zone you can easily fetch the marks because more likely questions used to get, and they're easy also. Okay, you need to have a good practice and good basic understanding. It's not memorizing. Of course you might be thinking, sir, I need to memorize, but I forget after some time. That's what you need to follow, a strategy, not just reading a book. Of course, reading a book along with the strategy, if you do it, then things will work for you. Okay, you follow any strategy which is given by anybody. Okay, I give a lot of such interesting strategies in our courses. Okay, or else it's not necessarily my strategy. Strategy is a strategy, anybody's strategy. One may have different strategy, it's okay, you can go for it. Yeah, moving to the next question. Seems to be a big one, but still I'm giving 40 seconds because it's a simple one. It's not a big one, it's a simple one. Yeah, it is a simple piece. Wow. This is also one of the out of 10 exams, I think in 4 to 5 exams you will find this series of questions. There are such series of questions in regarding power electronics. Okay, you'll get out of 10, almost 4 to 5 exams you'll get this kind of questions. I'm not talking about gate. Okay, it's hard to find repetitions in gate, question repetition, but concept repetition, of course. Concept repetition is quite possible. Anyways, time's up. Yeah, answer is this. These answer. You have to be clear with the waveforms. You have to be clear with the waveforms. It asks for RMS value here. Careful. RMS value of the current flowing through each thyristor. Okay. In case of a 3-phase fully controlled converter and feeding a constant load, each thyristor will be turned on for how many degrees? Conduction time is how much? Each thyristor will be on for 60 degrees, right? Each thyristor will be turned on for 60 degrees. Okay. And another question could be each leg, no, 60 degrees. How many degrees? Tell me. I forgot, I think. Each thyristor waveform, if I draw a pulse, constant one, let me just recall. This is a pulse. Yeah, sorry, I'm wrong. Each thyristor conducts for 120 degrees. Yeah, you're right, guys. Each thyristor conducts for 120 degrees, not 60 degrees. One leg will conduct for 240 degrees. This is 120, this is 120, total 240 degrees. So it is asked for one thyristor. Okay, I told you in the course how to find out the RMS value very quickly with this. That is 150 into square root of total time period is 360 by how much is the duration? 120 degrees. So this is the answer. If this would have been asked for a line current RMS value, then total line current is there for 120 plus 120, 240, will keep here 240 degrees. Okay. Yeah, that's a point. Let's move to the next question. Yeah, this is an easy one. I'm just giving 20 seconds for this. 20 seconds to answer this. Yes, Dinesh, you're right. 20 seconds to answer this. Answer it. We'll wrap it up. One more question is there. We'll end the session. These are 2 years, GENCO and SPDCL, both questions. Wow, good. Quick and good response. Most of you ran correctly. It's triangular. It's triangular. Because here we know voltage source inverter, the voltage will be a square wave. Okay. But it's an inductive load. It is asked for a current. We know the equation. V is equal to L di by dt. So I is equal to 1 by L integral V dt. Integrate this constant, you will get triangular. I done wrongly. Triangular like this. Okay. So answer is this. Clear? Last question. We'll end the session with this. 30 seconds is good enough for this, I think. Take 30 seconds and answer it. Take 30 seconds and answer it. Wow, very quick response. Good to see, Anusha. Very quick responses so far. Very good. Except I think the last question, RMS current, you answered almost everything correctly. Dinesh, you're doing good. And who else? Yeah, encyclopedia has been doing really good. Yeah, time's up. Karthikeyan also good. Nikhil good. Tarun good. Electrical engineering good. Yeah. The answer is voltage source inverter is normally employed. When do you prefer to keep voltage source inverter and when do you prefer to use current source inverter? We prefer to use voltage source inverter when you want currents to be smoother. Okay, when you want currents to be smoother, currents to be less harmonics, currents to have less harmonics, then we will prefer voltage source inverter. Okay, so under this condition, if you use a resistive load, you will still get a square wave current, because voltage is square wave, current will also be square wave. If you use a large inductance value, if you use a load with a large inductance, then definitely the shape of the output current will have less harmonics. So load inductance is large is correct. So these two are wrong. Now obviously source inductance, if it is large, maybe for rectifier or maybe for inverter, if source inverter is high, source inductance is high, that's making it CSI. Okay, that's making it CSI, and of course it won't allow changes in the input current. That's not required for us. Okay, so we prefer not this, we prefer this. How do you get this voltage source or current source inverter? We normally don't have a current source available, right? Generally we don't have that. Of course, if you use solar power, that's a different case I'm talking about. Except that we normally don't have that. We'll just emulate or we'll try to get the features of current source inverters by keeping an inductor in series with a voltage source. So this you can treat as a source inductance. That will not allow changes in currents. Okay? Yes. So that's it. That's it. Yes, Dinesh, you're right. That's the end of the session. Thank you for joining all. Thank you for joining this session, all of you. Share this session with your friends. We'll catch you up in the next session. Have a great day. Happy learning and enjoy learning. See you in the next session.